But you might think to yourself, let's consider something like a small protrusion coming out of one point on the Bloch sphere to represent its state. And if I were to rotate the Bloch sphere, then I could see that protrusion rotating. But the problem with this is that you are functioning as an external observer during this transformation. To understand why these all must be treated the same, imagine that there is a continuum of invisible observers that are all equal distance away from the Bloch sphere, such that when the orientation of the sphere rotates, from one observer's perspective, the orientation is rotating, but from another observer's perspective, the new orientation is identical to a previous observer's perspective. What this means is that the illusion and broken symmetry, based on the observation in a change in orientation, can only be a matter of perspective. But it's these differences in perspective that are precisely related to the difference in orientation between the detector and the state, which we know for a fact result in different observed realities. This should be mind-blowing, because we know that the different orientations of the protrusion must be treated equivalently. Otherwise, you're saying something like one of these observers' perspective is more real than the other. But in actuality, we know that rotating the state is a symmetry transformation, which means that when you do the transformation, nothing is happening at all.